are 3 steps when factoring by grouping. The first one is to factor out your GCF from the first 2 terms. Then you'll factor out a GCF for the last 2 terms. And then we're going to write the resulting product, which means we're going to write it in factored form. All right, so let's look at this first one. We've got a squared b minus 4ab plus 4a minus 16. So we're going to follow the steps that are listed above, and we're going to factor out of the first 2 terms. So if I look at just these first 2 terms, I can take an a out and I can take a b out. When I do that, I'll be left with, from my a squared, I took an a, so I'll just get an a. And from the b, I took a b, so I won't have anything there. The 4 will still be there. And my ab here, I factored it out, so that's all I'll be left with. Now we look at the last 2 terms. I can take out, or I can factor out a 4. That's all. So I factor out a 4, and I'm left here with just an a. And here I'd be left with minus 4. Now you might notice that what we were left with both times is the same. So that means that if we have AB times this quantity plus 4 times this quantity, well, we can rewrite that kind of like, think of it as doing the opposite of the distributive property. And we would have AB plus 4 in one set of parentheses and A minus 4 in the other. So now if you see, if I were to distribute AB to this set and 4 to this set, I would have AB times A minus 4 and 4 times A minus 4. So that would get me back to here. Right, so that's why we're able to take that step, because it's kind of like when we go from here to here, it's sort of like undistributing, if you can imagine that, doing it backwards. So we're going from here to here. All right, and this would be factored form. All right, so let's try it again. Let's try some more. In this one, I notice that all of my terms are multiples, looks like multiples of 5. So I'm going to start by taking a 5 out of everything, not just my first 2 and my last 2, but taking a 5 out of everything. So when I factor out a 5, I'll be left with 6x cubed minus 4x squared minus 3x plus 2. And now I'm going to take out, I'm going to look at my first 2 terms and my last 2 terms. So in my first 2 terms, I notice that I can take out a 2x squared. So I'm just going to leave this 5 over here hanging out. We'll put that back in at the end. So here I can take out a 2x, I'll put brackets here, 2x squared, and I'll be left with 3x minus 2, right? Because if I do 6 divided by 2, that gives me 3. If I do x cubed divided by x squared, I'm left with just an x. And here I'm dividing this by 2x squared, so I'm just left with the 2. Now remember, I want to be left with the same thing when I factor out here. So it's almost the same, but in order to make it 3x minus 2, just like I have in the first set of parentheses, I'm going to have to factor out a negative 1. So now when this is completely factored, I would have my 5 out in front. I take the two GCFs that I factored out and I put them together. And then I get the repeated factor and I just write it one time. And actually it would be better if I did this, because the 5 is not just times the first one, it's times the whole thing. Okay, let's try it again. In this next one, there's nothing that I can take out of all 4 terms. So I don't have to do that first step where I factor something out of all 4. But I can factor something out of the first 2. Both of these terms, they both have a b. That's about it. So because this term has an a, but this one doesn't, and this term has a 5, but this one doesn't, so all I can take out is a b. That's all they have in common. So in the first term, I'll be left with just a b, and in the second term, I'll be left with 5. All right, in this next one, I can take out a 4. That's all I can take out. There's nothing else. And then I'm left with a minus 3. Now, when you look at what I've got here in the parentheses here and here, they don't match. So I can't factor this. When an expression cannot be factored, it's called prime. All right, so let's look at this last one. If I look at my first 2 terms, it doesn't look like there's anything I can take out. Same thing with my last 2. But there may be a way that I could rewrite this to be able to take out something that's common. So maybe, I can try a couple of different ways of rewriting it. But let's see what happens if we switch these 2. So if I do CD minus 5C plus 4D minus 20. Now, be careful when you're moving around terms, because you have to be sure to take the sign in front of the term with it when it moves. So this will always be a negative 20 regardless of where it is in our string of terms. So now let's see if there's anything we can do. If I look at these first 2, I can take out a C, and I'm left with D minus 5. And with these last 2, I can take out a 4, and I'll also be left with D minus 5. So this one initially looked prime. But in moving the terms around, we found out that it actually wasn't. So this would be called a false prime, where at first it seems like it might be prime, but it's not.